All right, so this lesson I am going through simple counting problems. So first off, let's start with what is a counting problem? So basically, if you were asked to find out how many choices or how many possibilities for something to occur or that you have or how many options, that's what's considered a counting problem. And a simple counting problem is one that you can do by either listing all of the possibilities, or maybe you just have to do some multiplication and you don't have to really use any complicated formulas or anything like that. That's what makes it simple. So starting off with an example here, determine the number of ways a computer can randomly generate one or more such integers from 1 through 10. So we're just generating numbers from 1 through 10. And so here are our choices. How many ways can we get an odd integer? So for problems like this, I actually find it very helpful to write down your choices. I mean, obviously we're just writing down the numbers from 1 through 10. So how many of those are odd? Well, 5 of those are odd. 1, 3, 5, 7, and 9. So there are 5 ways to get an odd integer. So, simple counting problem. You just count how many you have. How about prime? Well, which ones are prime? 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. So there are 4 ways. If you pick one, basically, there are 4 different ways that you can get a prime integer. If you're just randomly picking a number from all of those. Integer that is greater than 9. Well, there is only one that is greater than 9. That's number 10. So there's only one way for that. And then integers that are divisible by 4. So your only choices for divisible by 4 are 4 and 8. So those are 2. So we have 2 choices for integers that are divisible by 4. So these are considered simple counting problems because you don't really have to do any calculations here. You're just literally counting how many choices you have, especially if you can write it down. So we're looking again at the generating one or more integers from 1 through 10. But the first example that we had, we were just picking one number. Here we're picking 2 numbers. So first one, 2 distinct integers whose sum is 9. So we have to look for, well, how are all the different ways that we can add numbers up to 9, basically. Let's see. So if I do 1 and 8, those add up to 9. 2 and 7, 3 and 6, 4 and 5. Okay, so I've written down, these are the combinations. We've got 4 ways that we can get numbers that add up to 9. So determine the number of ways a computer can randomly generate one or more such integers from 1 through 10, 2 distinct integers. We also have the alternate. So we can pick an 8 first and then a 1, 7 and then a 2, 6 and then a 3, or 5 and then a 4. So that we actually have 8 different possibilities. And you can do the same thing for 2 distinct integers whose sum is 8. So our choices are, we've got 1 and 7, 2 and 6, 3 and 5, and then 4 and 4, because you could pick the same number here. And then you could also have the other direction. Now 4 and 4, that's not really, it says distinct integers. So 4 and 4, those are not distinct. Distinct means that they're 2 different integers. So even though that adds up to 8, that's not included in our question here. It says 2 distinct integers whose sum is 8. So I can also pick a 7 and then a 1, 6 and then a 2 and then a 5 and a 3. So we have 6 different choices here. Let's take a look at another example. So a student has to take 1 course of physics, 1 of science, and then 1 of mathematics. She may choose one of 3 different physics courses, so we're just calling those P1, P2, and P3. One of 2 different science courses, so S1 and S2, and one of 2 mathematics courses, M1, M2. And how many ways can this student select the 3 courses she has to take? So the first method is to basically make a tree diagram, which allows you to write down all the possibilities. So you start with your student, and let's just say, okay, first you can choose 3 physics courses. So her choices are P1, P2, or P3. So she has to choose at least one of those. And then she has to pick 2 science courses. So after she picks her physics course, she has to pick 2 science courses. So each choice of the physics, there's now 2 science to pick from after that. And then she has to pick 2 math courses. So after she picks through her science and picks through her physics and her science, then she has to pick math. So now there's 2 choices after that. So you can say, if we just look at the top tree, you can take physics course 1, then she could choose science course 1, and then she could choose math course 1. Or she could do physics course 1, science course 1, math course 2. So we're listing all of the different ways that she could choose her courses. And then once you finish filling out your tree, you look at all of those, the final branches, the ending points here, and you count how many those are. And that tells you how many options there are for how many different choices or ways that she can select these 3 choices. So if you count all of these up, we get 12. So there are 12 different ways that she can come up with her combination of physics, science, and math courses. So not too bad if you're only having a few choices here, but this method is not ideal if you have a lot more choices. You know, like maybe instead of 2 math classes, there are like 6 math classes. Or you have to choose more combinations of courses. You can see how this can get kind of unwieldy. So there is actually a second method, and this is where we just do multiplication. So the way that it works is, and actually I just realized that my camera is blocking my words, so let me just move it down. Okay, just realized that. Okay, so we can do multiplication methods. So first, we have the number of physics courses you choose from. So then you have the number of science courses that you can choose from. And then you have the number of math courses that you can choose from. And so what you do is you literally write down, okay, there are 3 physics courses, there are 2 science courses, and 2 math courses to choose from. And you literally multiply these together. 3 times 2 times 2. So 3 times 2 is 6. 6 times 2 is 12. And you get the same answer much faster. So this is basically still considered a counting problem, a simple counting problem. And all you have to do is just multiply the number of choices you have for each set, providing that one doesn't affect the other, that your choices of the physics course doesn't affect your choice of the science or the math. Like they're distinct, different courses. They don't affect each other. So using that multiplication property, that is called the fundamental counting principle. So when we deal with probabilities and things like this, we use E to represent events. So an event would be picking a physics course, or it could be tossing a coin. And so our counting principle says 2 events, but this can be generalized to 3, 4, 5, however many events that you want. So if the first event can occur in M1 different ways, so like physics, we can pick 3 of those. And then after that occurs, your second event, picking a science class, can occur in M2 different ways, so 2 different ways. The number of ways the 2 events can occur is multiplying those 2 together, M1 times M2. So that's what we just did on the previous slide. We had 3 events, but you just multiply all of your choices together, and that gives you the total ways that it can occur. Now, this works if you're selecting with replacement, so that means that you can reuse choices. And it also works if you're doing without replacement, which means you can't reuse choices. Once you picked it, you can't pick it again. But you just have to take that into consideration when you're creating your multiplication and when you're considering, well, how many choices do I have after this first one occurred? If it's without replacement, then generally your choices go down. Like if you're picking 2 letters from the alphabet and you can't repeat letters, you have 26 choices for the first one, but then if you can't repeat, there's 25 for the next. So that would be an example of without replacement. But if you can choose the same letter, it'd be 26 and 26. But either way, you're still multiplying them together. Okay, here's an example. A small college needs 2 additional faculty members, a chemist and a statistician. There are 5 applicants for the chemistry position, and there are 3 applicants for the statistics position. And how many ways can the college fill these positions? So we could solve this by making a tree like we did for the courses, but we can also just use the multiplication, the simple counting, the counting principle. So we just have the choices for our chemist, and then we have our choices for this statistician. And so there are 5 applicants for chemistry, 3 for statistics, and so you multiply those together. There are 15 different ways that we can fill these positions. Obviously, you're not going to randomly choose. You're not going to, just say, oh, okay, I'm going to just randomly choose 1 and 1 and whatever, but those are the different combinations that we can get. In how many ways can you answer a 6-question true-false exam? And assume that you don't skip any questions. You don't omit any questions. So we've got 6 questions. 1, 2, 3, 4, 5, 6. And it's true-false, so there are 2 ways to answer each question. So we've got 2 times 2 times 2 times 2 times 2 times 2. So if you notice this is basically 2 to the 6th power, which should be 64 if I'm doing my mental math correctly. Because let's see, 2 to the 3rd is 16, 16 times 16. 2 to the 3rd is 8, 8 times 8 is 64. Yes. 2 to the 4th is 16, 2 to the 3rd is 8. So there are 64 different ways you can answer a true-false exam if there are 6 questions. So in how many ways can you answer a 12-question true-false exam? Again, you're not skipping any questions. So we can just skip the whole process of 2 times 2 and 2, because if you notice this pattern, this is just literally going to be 2 to the 12, which that I definitely need a calculator for, because I don't know 64 times 64. Where did I put my calculator? Okay, so 2 to the 12th, 4,096. So there are 4,096 ways that you can answer a 12-question true-false exam. And this is my last example. In a certain state, each automobile license plate number consists of 2 letters followed by a 4-digit number. So these are letters. And then we've got 1, 2, 3, 4. So these are all numbers. To avoid confusion between O and 0 and I and 1, the letters O and I are not used. So that means instead of 26 letters, we now have 24. How many distinct license plate numbers are possible in this state? So we've got 24, and it doesn't say that we can't reuse letters. So we've got 24 choices for both letters. And then think about our numbers. We've got 0 through 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 numbers. So even though it goes 0 through 9, 0 counts. So we've got 10 choices for the numbers. So 10 times 10 times 10 times 10. So I can simplify this as 24 squared times 10 to the 4th. And so I'm going to just do that on my calculator and make sure I actually type it out. Oh boy, this is very large. We've got 5,760,000 possible license plate numbers. So, hopefully plenty for everybody in that state. Though, of course, I'm sure there's some that they won't allow because, you know, maybe it spells out something that they don't want to allow or things like that. But that is technically just following those rules, the number of distinct license plate numbers that are possible. And distinct means you're not going to repeat license plate numbers. And this is assuming you're not going to have two that have the same combination. So these are how you do simple counting problems. When you have things that are more complicated, then you have to use combinations and permutations, and that is the next topic. So you can find that in one of my other videos. So hope this helps. Bye.